Hello, welcome to our topical solution series on IGCSE and Maths 0606. The topic we are going to look at in this video is on permutations and combinations. The questions that we have chosen for this video is taken from May-June 2019, paper 1-3. You may get this paper ready and we may do these solutions and happily learning together. Let's go. Here, before we hop into the solution, I would like to run through for all of us a quick revision about the whole topic. Under this topic, mainly, we are going to use three main tools to figure out how many ways something given to us, a certain number of choices of things, and to work out how many type of ways or arrangements can we display them around. Okay, these three tools are, as I have put down here, factorial, and the calculator key will look something like that, X with an exclamation mark. And the permutation, the calculator key looks like NPR, in combination with calculator key as NCR. Out of these three, how can we organize them for our easy learning? Well, I would recommend we break them into two categories. The category on factorial and the category of permutation and combination in one group. Why do we organize them that way? Simply because for factorial, you will notice that in a certain kind of arrangement with X numbers of choices. Example, if X is 5, that means you are given 5 items. For example, like 5 books, 5 pictures to be displayed on the wall. Those conditions that for each time when you arrange the 5 pictures, you have the liberty that all of them can be displayed together each time. You are not limited to have to choose out of that 5 each time. You can only pick 2 out of them. Well, that condition gives you the clue that you will use factorial. On the other hand, for permutation and combination, you are not that free to choose. For example, in this case, you are given, for both of them, you are given n number of items. For example, n is 7. And each time out of the 7 items, you are not having the freedom to pick all the 7 at each choice. You have the limitation that out of the 7, maybe each time you are constrained by 4. Out of the 7 choices, you can only pick 4 each time. So that criteria or scenario is pointing you away from factorial, but going towards either permutation or combination. Then out of these two, how do we differentiate when do we use permutation and when do we use combination? Yes, as stated here, for permutation, when the order of the choices matter, the order of the item being arranged matter. Okay, for example, for the password or passcode or committee of people, so the arrangement 1, 2, 3 is certainly different from 2, 1, 3, even though you have used all the 3 seems to be similar number, but the order of arranging the number makes different between them. Okay, so that occasion we will go for permutation. And the other one, yes, is when the order of arrangement does not matter. For example, you have 5 people in your room and you have only 3 chairs. In other words, for each time, only 3 people out of the 5 can take a seat. So who take the seat and which seat is taken by who make no difference. So that occasion, combination is your 2. Now, with that quick revision, let's move into the applying of this knowledge to solve this question. Okay, in this question, it's spread over to 2 pages. Now let's deal with the first page. This is from page 12. Part A. Jack has won 7 trophies for sport and wants to arrange them on a shelf. He has 2 trophies for cricket, 4 trophies for football, and 1 trophy for swimming. Well, find the number of different arrangement if there are section 1, 2, and 3. But before we go into the various sections, let's analyze and dissect the information or dissect the question so that we organize the information given to us. From Jack's trophy, altogether 7 of them. And out of these 7 trophies, 2 of them is the one that he has won from cricket game. And out of that 7, 4 are from football and 1 from swimming. Okay, with those information, now you're ready to tackle the question. Let's take them one at a time carefully. For section 1, there are no restrictions. I am sure this is the favorite of all of us, where there's no restriction imposed on our choices. In other words, for Jack, all he has to do is he just needs to have a shelf that is big enough and provide enough space, because Jack has the liberty to display all of his 7 trophies at one go. Therefore, we know out of the 3 tools, we will go for factorial. And without restriction, it makes our job so much more easy that all the arrangement that Jack can have is 7 factorial. Key into your calculator 7 factorial and it will display for you 5,040 ways of arrangement that Jack can proudly, happily display all his trophies. Okay, we go to section number 2. The football trophies are to be kept together. Here's the little conditions that he wanted to display his trophies. He doesn't want it to be randomly displayed. He doesn't want it to be displayed in any order, but in fact, he wanted to organize all the trophies from football must be kept together. Well, I have put down the display for our easier visualization. Then I put in F stand for football, C stand for cricket, and S for swimming, respectively. And the 4 trophies of football that I put in there, F1, F2, F3, and then F4. The conditions say Jack 1 to keep them all together. They cannot be separated. They must be displayed together. And then for cricket, he has cricket 1, cricket 2, and for swimming. Now, what we're going to work out is, in the very first step, we will just work out overall, if we group all the football trophies all together, and we consider all these 4 trophies as one unique item. And when you consider that, we will count how many distinct or different items that we are going to move about. Then you will have football, consider as 1, cricket 2, cricket 3, and then the swimming. So we have 4 items that we can juggle around. Now, that's not the end of the story, because bearing in mind, among the football trophies, there are 4 distinct trophies that he probably won at different time at different championships. Therefore, we are going to toggle around among these 4. There could be another 4 factorial, because each of them is considered one distinct item by themselves. Therefore, among the football, we have 4 distinct items. And how many ways we can arrange among the football trophy? We got it by 4 factorial. Now, you have come to the end of calculating section 2. The total arrangement to arrange all football trophies kept together, and the other 3 trophies, you will get this by 4 factorial from this condition. And the 4 factorial when you juggle within the football trophy among themselves. By doing this, you have arranged out the perfect working and calculation. The next thing will be the help from your calculator. Key in 4 factorial, multiply 4 factorial, and comfortably you get for yourself 576 different arrangements Jack can have. Now we move on and let's look at the scenario. The football trophies are to be kept together. Okay, that was the condition he wants from section 2. But this time, his requirement extended also for the cricket trophies. He also wants the cricket trophy to be kept together. Now, as I display in the drawing here, the football trophy, all of them has got to be put together. It's something like it has to be bundled together. All right, it has always to be together. And then with the added condition, the 2 cricket trophies also cannot be separated. Therefore, now you use the same logic. Okay, first step, after the bundle up of the football trophies and the grouping of the cricket trophy with 1 swimming trophy, you will have 3 distinct or different items to juggle around. And that gives you 3 factorial. Then we move on. Within the football trophies, you have 4 distinct football trophies, 4 different football trophies that you are going to juggle around. And that gives you, as you see in section 2, 4 factorial. Now you go forward one more step, then to analyze within the 2 cricket trophies. They are considered 2 distinct items, 2 different trophies that you will juggle around. Okay, and that is given to us. There's going to only 2 choices. You can put this trophy here and this trophy here, or the other way around. Okay, now do not worry about that because we have calculators to assist us. Now, we just put all these 3 analyses together, total arrangement for Jack to have all his football trophies kept together and all cricket trophies we kept together, and you will work it out 3 factorial from the 3 distinct items, and then 4 factorial from the 4 distinct football trophies, and 2 distinct items from the cricket trophies. Then with the assistance from the calculator, yes, you are going to see 288 different ways of arrangement that Jack is going to have. Okay, so far so good. All right, let's move on to the next page. Okay, part B. Wow. A team of 8 players is to be chosen from 6 girls and 8 boys. Find the number of different ways the team may be chosen if all the section given below. Now, we're going to pause, and as usual, we're going to analyze, dissecting the questions carefully and organize the information given to us. Now, a team of 8 players. That gives us that the limited places to form a team is 8. Okay, and we're going to look at from how many choices can you choose or select to fill in these 3 places in the team. Then was given to us from 6 girls and 8 boys. Now what I'm going to put, what I display here, I just put it down. 6 girls and 8 boys. Well, altogether you have 14. Okay, so that is displaying for your visualization. You have 14 choices, and out of which 6 girls, 8 boys. But out of this, not everyone can fit into the team. They have to compete among themselves, or you as a teacher or captain, you will have to select among these 14 to fit into a team of 8. Now, section 1. If there are no restrictions, this is certainly our favorite, because when there is no conditions imposed, we will just easily, from total, how many children? Yeah, there are total 14. And that's given from us from 14, we're just going to choose 8. And in the notation of NCR, I have simplified the meaning of N is from the number of choices, and the R as the how many items you have to choose from the N. That substitute the information given to us from 14, we are going to choose 8. There you go. With a little key in of your calculator, you will know that there are 3003 ways to form a team of 8 people from 14 choices of children or teenagers. Yeah. Okay. Now in part 2, all girls are in the team. Okay, you have noted that condition has been imposed and limited to your choices and the way you form your team. The conditions given to us is that all the girls must be in the team, not one of them to be missed out from the selection. Okay, with that condition, again, out of the 3 tools, you were still going to use combination, all right, because the order who is being chosen into the team doesn't matter. Therefore, now we go and look at the condition given to us, and I display from here. From 6 girls, 8 boys, the condition restrict you that all girls must be chosen. By all means, they are compulsory to be chosen. Therefore, from all the 6 girls, 6 must be chosen. And that leave for the boys, out of the 8 players in the team, it left only balance of 2 vacancies to be filled in by the boys. Therefore, we have, from this chart, we know from 6 girls, choose 6 girls. And then from 8 boys, choose 2. Those are the clear information that we have drawn from the question and the condition respectively. Therefore, now we're going to shift all this information into our working and layout. The number of ways equals to from 6 girls, chosen 6. Because all girls must be chosen, not one is missed. And with the multiplication, the 8 boys will be chosen. Out of the 8, only 2 of them will be competing for the 2 balanced vacancies. And that's how we get 6C6 from the girls section and 8C2 from the boy section. And by putting them together and keying into your calculator, and once again, you note that you don't have much choice, but you only have 28 ways. If you are being limited with the conditions that all girls must be in a team. Okay, now we move on to the third one. Also conditions being imposed upon your selection of your team. This time they say at least 1 girl is in the team. Well, it is slightly different from the section 2. Section 2 is all girls must be chosen, not even one is missed. But this time, they give some liberty, but they mention here, at least 1 girl must be in. The rest can be filled up with the boys. Well, I have listed down for your understanding. That means for first option, at least 1 girl, a balance of 7 from the boy. Or option 2, The girl take up 2 vacancies and the balance 6 take up by the boy. Or the third choices where the girl take up 3 and the balance 5 take up by the boy. Or option 4, the girls take up 4 and the balance 4 take up by the boys. Or option 5, the girls take up 5 of them and the balance 3 vacancies to be filled by the boys. And then the final 6th option is when 6 girls are chosen and the balance 2 places given to the boy. And if you happen to ask why are we not proceed to 8 girls and 1 boy? Yes, if you carefully looking at the choices that you have, the girls all together, you only have 6 available. Therefore, you don't have enough girls to take up 7 places in the team. That's what you have. And from another perspective, you can consider that also equally meeting the conditions, at least 1 girl is in a team. That scenario is if you take the all choices that you have, then except 1. If you take all the condition, except what? Except when no girls is chosen and all the boys take up the except no, this one's supposed to be okay, no, supposed to be all the 8 places take up by the boys and then no girl at all in this choice. Okay, so now, yes, if you were to look at that, it is much easier if we take from this perspective. And from the display of the working, that is what we are going to do. We take the total minus out the combination where no girls is selected. Okay, and what is the total are we talking about? All the way back up to section 1 when there's no restriction, this is the total. This is the total that is available for you. Yes, this is the total. And therefore, you're going to take 3003 as the total combinations and you take out when there's no girl and the same meaning 3003 take up all boys and the all boys would means what? Out of the 8 boys chosen 8 places. Okay, by doing that again you will notice from your calculator 8C8 gives you 1 and therefore 3003 minus 1 and that gives you 3002 ways to form the team of 8 players with at least 1 girl is in the team. Okay, so now with that, you have concluded this question. And if you look at the whole questions, wow, that is quite an achievement that you have learned. Okay, so it's time for us to say goodbye again. And last but not least, as usual, wishing you always happy learning and looking forward to see you in the next video. Bye-bye.